But
Hello, Mark.
hello, Joanna.
How are you doing today?
Absolutely fantastic and delighted to be with you today and delighted to be with our viewers that decided to watch today's video, which has a very interesting topic, which is.
So today's episode is about the Baerwald Loefgren Stevenson debacle.
And debacle is the right term, really.
You see, a lot of heated discussions are constantly going on forums, audiophile forums, are about the Baerwald Loefgren Stevenson alignment methods, and they are mainly about which of those three is better. Can you tell us more about all of that, and who are those guys?
Well, who are those guys? This is a nice question because I made a research on the web and I found very, very little, mainly about Bearwald and Loefgren, a German mathematician on the dawn of the 20th century. They published a couple of theoretical mathematical studies in relation of Thornham geometry. About Stevenson, I couldn't find a single thing. It's even less know that those two German guys. And the study was absolutely theoretical because we are talking of the beginning of the 20th century, where I-phi was a concept absolutely unknown. Where those still this shellac 78 round per minute. And later on in the 60s, 70s, and even 80s, where all these, the vast majority of toners we use still today were designed, nobody really cared about any of things. Every manufacturer's designed their toners with a geometry they thought better.
So yes, I agree with you. Any information I could find on internet were about Baerwald and Loefgren and about their theories. So all theoretical concepts, nothing about any practical use and importance. While you listen to your recording, they were all made around 30s in the previous century.
The reproduction quality in the 30s was so low that anything goes. So, as a matter of fact, all this Bearwald Loefgren things is quite new, because it has been discovered in the last decade or maybe 2 decades, and heating up the discussion about which is better, which is the panaceum of all problems in audio reproduction, which is not. Sorry.
So yes, there are very present. Discussions are very present on every kind of audiophile forums. But for example, on Vinyl Engine, we can find definitions.
Oh, the Vinyl Engine. Vinyl Engine is a great site. It is a source of information that is fantastic. I believe. If you don't already, leave the link below. And this is what theoretically these three different systems might give you. The Stevenson, a site from Vinyl Engine, is a variation of Loefgren geometry. Change the glasses. Age is not a good thing. It's a variation of Loefgren geometry, optimized for low distortion in the inner groove, at the expense of increased distortion elsewhere. Compared to Baerwald and Loefgren B, you will get a lower distortion for the last few millimeters of the record. Baerwald, which is identical to Loefgren A, as my note, they arrived to the same conclusion probably, minimize and equalize distortion at the 3 weighted tracking error peaks, resulting in moderate distortion between the inner and outer groove. And Loefgren B minimize distortion between the inner and outer groove, resulting in the lowest average RMS distortion, at the expense of a slightly higher distortion close to the inner and outer grooves. That's the end of it.
Yes, I read about that, and everyone repeats the same definitions, but with divisions on which one is the best, and which is the best, which one of those three is the best, and are there any alternatives, methods of tone arm alignment?
If you ask me if it's the best, none of them is all of them.
How so?
Yeah, well, I must say that the average audio aficionado doesn't understand what lay at the bottom of this matter. We manufacture about 180 different arc protractor that helps to very precisely align cartridges in about 2000 tonams, model of tonams and decks.
And we have three of your arc protractors here, one of which we can read Riga Loefgren A.
Yes, this is made based on Riga geometry, but is slightly modified to reach the Loefgren A or Baerwald tracking parameters.
Then we have the second one, Lin.
Lean, right, absolutely not conform to anything we of the three we spoke before. And
Number
here
three?
we have Kuzma, who is still even more far away from the three canonical tracking we saw before. So this means that every manufacturers decide to have the geometry and the things fit better for their users.
And I believe you've made video about the
Yes,
tone arm alignment.
Yes, we have a video. I will also put the link in the description where it's explained how the geometry works and how are calculated the tuning points in the tuning points of where the tracking error is zero. Well, the bottom line is that there are customers that are quite disappointed to learn that their tone arm does not comply with any of these three kind of alignment.
Because those customers, they may believe that these three methods of alignment are the best, I suppose.
They are driven to believe so, and there are customers they are asking to have custom designed protractors for their tone arms to comply with one of those three paradigms we saw before. And this is not all the time possible.
Can you give us an example?
Yeah, I will show you. I took from the vinyl engine. The vinyl engine is a very interesting calculator where you can put the parameters of your tone arm and you calculate all the distortion, tracking error for your tone arms, and it compares with the Loefgren A, Baerwald and Stevenson. So bearing in mind that in the parameters of your tone arms, you have one that you cannot change, which is the pivot to spindle distance, because it's where the tone arm is mounted on your deck. Let's say this example now. Let's take an hypothetical tone arm with a pivot to spindle distance of 222 millimeters, and I put this in all four different forms. And as a custom, I put a parameter of my tone arm, which has 15 millimeters overrun and 21 degree offset angle, and I run the calculator. Calculator tell me, in my tone arm, if I want to achieve a Loefgren A or Bearwald, I have to change my overrun from 15 mm to 16 mm 38, or 16 mm 85 for Loefgren B, or 40 mm at 52 for the Stevenson. While I need to also change the offset angle from 21 degree to 22.52 2247 or 2149 respectively. Now, as you well know, in the most of the tournaments, in the cartridge mounting as shown, there are these isles. You can move the cartridge a little bit forward or a little bit backward. This is not made for change the geometry. This is made because every cartridge has a different distance between the needle and the mounting hole, because for different reasons. You need a longer cantilever, the magnet are placed somewhere else. But you can use this to change the geometry if the difference is very small, because changing the overhang a lot, it might not be possible because your needle will not be able to reach the arc. In this case, yes, you can quietly say that 1 millimeter and nearly 2 millimeters and a half, 1 millimeter and a half in overhang and 1 degree in offset angle, you can still play with it and achieve one of these three. But this is not possible with all tournaments.
Can you give another example where it's not really possible to adjust this?
Let's say I take this SACWE 506, which is a very strange tournament, sounding very well, a very good tournament, but it's quite unusual, let's say. And let's say we put on the pivotal spindle the pyramid 286 for all four, and then overhang 9 millimeters and offset angle for 14 degree and 4, and we run the calculator, and here we see that with our SACWE 506 we should change our overhang from 9 millimeter to 12 millimeter 89 for Loefgren A or Baerwald, and 13 millimeter 27 for Loefgren B, and 11 millimeter and 41 for Stevenson. The difference is very big. Is nearly 4 millimeters and a half for Loefgren B.
You're exceeding even 4 millimeters.
Absolutely. You have 90% chances, if you can even move as much as that, so that your needle will be out of range. The offset angle also is not funny, because from 14 and 4 degrees to 17 and 79 or 1776 is quite a twist. You might not be able to twist this cartridge in the head shell so much. So in this case, if you have this kind of tournament, or a tournament that has some extreme geometry like this, you cannot achieve any of these geometries.
So I believe the audiophiles are very much concerned about possible distortion. That's why they're looking for the best methods of alignment.
Well, on average, an audiophile, when they hear the word distortion, gets frantic and already see pictures of screaming speakers or unpleasant sound, something like that. And they don't understand what lie on the bottom of this matter. Technically speaking, distortion is something that when you have an input and an output, and the output is different than the input, the difference is the distortion. But this doesn't mean that this brings of bad sounding, doesn't mean that it's unpleasant. When we're talking about tracking distortion, the distortion we are talking about is phase error, and it's not what is generally understood as distortion. I will show you something. I made a short presentation. It's a bit crude because I don't do generally these kind of things. This is a crude representation of a record groove, which has two channels, identical channels, left and right, playing the same simple sine waves as a tone, and it's identical. And this is our needle that is laying perfectly vertical to the axis of the groove, is tracking arrow 0. Now, a tracking arrow is something like this. It's greatly exaggerated. When is a tracking arrow? You have one wall of your needle touching the one side of the record before than the other. These two. This is what we call a phase error, because this part of a needle, one channel, will play the groove slightly earlier than the other one. Now, of phase errors, there are many inside your systems. There are phase error given by a tracking error. There are phase error given, like we will see later, given by your geometry of your needle. There are phase errors even into your amplifier, because in every stereo amplifier, the two channels are not identical. One will be slightly faster than the other, and this the reason is because there are tolerances in the component inside your amplifier. So this phase error can add or can be partially or totally cancelled by phase errors existing after in the other part of your system. Now to put things into perspective, let's see what mean 1.5 degree of tracking error. Look carefully at this drawing. This is your needle at 0% tracking error. Look carefully. Click. Did you see anything?
No, I can't see any difference. It's still the same for me.
No, it didn't. It did move 1.5 degree.
Oh. Did it?
Yes, this is 1.5 degree. So it means the phase error generated by the misalignment of 1.5 degree in a tracking error is minimal. Moreover, let's see now the effect of the geometry of your needle on the groove. I stole this from the internet, sorry, but I hadn't time to do something like this. This is a bit exaggerated, a highly modulated groove of a record. Now, we have different kind of stylus. First, this is spherical stylus. There still exist cartridges with this kind of styluses for people that don't like very precise sound. As you can see, depending the modulation, the needle is touching the sides, the walls of the groove with great phase error. Here, the horizontal line are tracking 0, and the arrows is the effective point of the needle touch the walls, and is what is actually the needle is reading.
It even changes direction depending.
Yes, the phase can be plus or minus depending. So these kind of stylus generate a massive phase error. Now let's go to elliptical stylus, which is a stylus using 95% of, or let's say budget cartridges below £300-400. Is better than the spherical, but still we have quite a remarkable amount of phase error. Then we arrive to the line counter stylus, which is also called a Shibata. There are different profiles for cartridges from £400 up. And there are, if you look closely, there is still minimal phase error, but they are very, very good. We ignore the optimized line counter stylus because it's for the filter ridge. For cartridges, it costs several £1,000.
Not for everyone.
Not for everyone. So now you can understand that uh, uh, discussing about a difference of 0.5 degree in tracking error between one method and another is, in my opinion, absolutely and exclusively theoretical. If you ask me, in practical terms, there is no difference.
But still, the audiophile want to align, and they find that the properly aligned cartridge sound way better, don't they?
Absolutely, they are absolutely right. A properly aligned cartridge sound way better than a not properly aligned, but this has nothing to do with Baerwald, Stevenson or Loefgren. I show you now what are the effect of a badly aligned cartridge. And it's not difficult to badly align a cartridge even with a protractor. If you use these protractors, generally use protractors, we are not dedicated and don't give you a clue about the effective length of your cartridge. It's very easy to have several degrees of misalignment and be convinced that you have the cartridge aligned. Now, here again we have our hypothetical simplified groove. Here we have our needle is zero track aligned, and now we have it misaligned 15 degrees, quite a lot. Now, this is the direction of traveling of our groove. Now, we have to take in consideration two things. One, the speed of the groove is very high in relation of the surface of the contact surface of a needle in terms of multipliers. And the pressure of a needle on the groove, even if it's only 2 grams, taking into consideration that contact surface is less than a human hair, this 2 grams is a very remarkable force. So we have a very remarkable force on the wall of our groove, traveling fast and vibrating several thousand times a second. Now, this is what's happened when the needle, the cartridge, is badly misaligned. The side of our needle hitting sideways the wall of a groove, they start to generate torque forces in one direction and one another, straining badly the needle, the cantilever, and the rubber suspension, generating resonances, additional vibration is sound, and this is the bad sounding cartridge because of bad alignment. It's not the 0.5 degree of difference that make a difference. This is the real difference in your sound. So you need to have properly aligned. You're perfectly fine to be aligned with the parameters who designed the Tornam gave for his Tornam. They're not idiots. They know what they're doing.
So this is your advice for everyone watching us. Please align your tone arm accordingly to the manufacturer parameters.
Yes, you can even play with this Bearwald, whatever, if the modification are very small, it's a millimeter here and there, 1 degree of offset angle is fine, but well, the proof of the pudding is one, and I challenge anyone to do this simple experiment. Put a nice record on and start listening. Close your eyes and try to guess when the needle is hitting the null point where the tracking error is 0. Unless you are not coming from planet Krypton where everyone is Superman and super hearing, simply you can't.
Thank you, Mark, for a very interesting conversation. Thank you for your all explanations. Thank you for watching us. Please, if you have any comments, observation, if you want to share your opinion about this topic, write to us in the comment section.
Yes, everyone is free to disagree, but I would like to know your opinion, but add to your opinion some solid arguments. Because all what you find, all this blah blah, yada yada, on forums, etc., are not based on any technical and practical proof that there is indeed any sensible difference in your listening experiences.
Thank you for watching us, and see you the next time.
See you, and enjoy the music.
Enjoy.
Cheers.